Ladies and gentlemen, please welcome Mike Schrepfer.
All right. Welcome to day 2, everyone. Thank you for coming back. Today is going to be a lot of fun. I hope you're ready, because we get to talk about the future. Facebook is a technology company with a clear mission, and I've never heard that mission so clearly articulated as Mark did yesterday, how important it is for us to use technology to bring humanity together. And so we think about our 10-year vision, what we're going to spend this morning's keynote talking about. Everything we do in that 10-year vision is designed to support our mission of connecting the world. It starts with connectivity, building services that can scale to the entire planet, and connecting the billions of people around the world that aren't yet on the internet. Moves to artificial intelligence, so we can build truly intelligent systems that help all of us deal with the massive information online. And goes to virtual reality, where we can build truly immersive experiences, where we get a sense of presence, like we're in another world, and ideally with another person. Building deep personal connections with people who may be tens or hundreds of miles away. So let's dig in. Let's start with connectivity. For us, connectivity starts with the basics. It means building out infrastructure that scales for the entire planet. And that starts with our data centers, where we've built 4 of the world's most power-efficient data center sites. In the last year, we kicked off construction in 2 new regions. And putting this all together, once we're done with all of our construction projects, we're going to nearly double our entire data center footprint. This is going to give us the power to serve all of the things you saw yesterday, from live video to global messaging, and powering all of the things we're talking about today. And inside those data centers is chock full of technology designed and developed by Facebook engineering. Everything from the electrical systems, the cooling systems, the racks, 8 different classes of servers, storage systems, the network backbone, all of this equipment designed for power efficiency and cost efficiency, to give us and you the power to scale services through the whole world. And this is the best part. We've taken this technology and we've given it to the community. We took the ideas all of us know and love from open source software, things like the Linux kernel, Apache web server, and we brought it to hardware. Just 5 years ago, we kicked off the Open Compute project. And in that time, we've seen the participation of most major equipment and cloud computing providers. Folks like IBM, Intel, Microsoft, and most recently, Google, have joined us together to innovate in the core technology that all of us use, so that we can share and collaborate, make that technology cheaper, more available for the whole world. Once we have that hardware infrastructure, we then need the software platforms to build on top of it. For that, it's HHVM, a state-of-the-art virtual machine that we use to host most of our code on the servers. We've achieved at least a 10x efficiency win just through software in this, and we've released this in open source. So sites like Wikipedia are also using this, getting at least a 5x efficiency win on top of that. Incredible ability for us to scale. And then once you've got all this awesome scalable infrastructure, the rubber really hits the road when you have to build great applications on the web and on mobile. Last year at F8, I was really pleased to announce that React Native had gone open source. And in that short time between last F8 and now, we've seen massive adoption. Everyone loves building on React Native. And we've seen massive contributions. More than 600 people have contributed to the GitHub project in the short lifespan that this project has existed. And I'm really excited to have Christine talking just a little bit later in this keynote about React Native and all of our open source efforts. She's got some exciting announcements there, so stay tuned for that. But once we built this awesome scalable infrastructure, we're faced with the second problem. How do we get the billions of people, more than half the world, connected to the internet? And that's where projects like Free Basics and the Connectivity Lab come in. We need to solve some of the core problems in terrestrial, in building systems that can provide internet access much less expensive by going in the sky and going into space. We're very fortunate to have Jay Parikh talk a little bit later in today's keynote in detail about some of our latest projects here. They span things like breakthroughs in terrestrial RF transmission to allow for high bandwidth transmission in urban and suburban environments, laser-based communications that allowed us to build backbones in the sky at a fraction of the cost it takes to put fiber cable in poles or under the ground. And Aquila, are aircraft designed to provide internet access to remote regions of the world, the wingspan of a 737, and weighs between 800 to 900 pounds. And projects we're doing with partners to bring satellite-based internet access to people all over the world. And the best part? Just like OCP, we're bringing the community together to share this technology. So it's not ours, it's for everyone in the community to use, so that we get this in the hands of real people faster. We launched the Telecom Infrastructure Project. We brought together hundreds of OEMs, operators, and other technology providers to take this technology, push it forward, and get it in the hands of real people. Open source, open compute, telecom infrastructure project, providing the infrastructure for the whole world, for you. Next up, let's talk about AI. Despite all the excitement about AI, the most common question I get from people is, why does Facebook care so much about AI? Kind of don't get it. I kind of pop open my app, look at my news feed, see some stories from my friends, like what's the big deal here? And the thing you don't see, and I get why you feel this way, is that of those 15 or 20 or 30 stories you might have seen, there are likely thousands of candidate stories we could have shown you in that second. And so the first job of AI is to make sure that in any time you open the app, we show you the absolute best content we possibly can. I like to think of it as if we invited you over to our offices for the afternoon, you cleared your afternoon, you sat down, and we showed you, here's the 2,500 stories we could have shown you. You sort them, and you say, these are the 15 that I would most like to see. That we do that via AI, but we do it for billions of people a day, billions of times a day, when people are posting 1 billion posts a day, 2 billion photos a day, watching hundreds of millions of hours of video. So we're doing AI at massive scale. And this is the power of AI. We can do it for the whole planet. And so over the last year, we've invested dramatically in the core AI infrastructure. Right this second, we're doing 6 million predictions per second across the AI systems on Facebook, and this is growing very rapidly. Over the last year, we've had massive adoptions of our AI platform. More than 25% of the engineers at Facebook have used our AI systems to improve one of the products on Facebook. And we've been rapidly building out our compute infrastructure. We've tripled the size of our training cluster. We're now well over 40 petaflops of capability and growing. And again, this is built on Big Sur, which is a server design that we've contributed to OCP, so you too can use the exact same training infrastructure we use in order to train your AI systems. And we're very lucky to have Joaquin talking later in today's keynote in detail about what's going on and the state of the art of AI and how we're applying it at Facebook. But this is just today. In order to really achieve our mission of having systems that are smart enough to manage the information in the world for you, there's a whole host of problems we have to solve. Computer vision, natural language, building systems that can plan and can really reason. And if you take one of the most promising areas of artificial intelligence, computer vision, a place where we're making lots of progress very rapidly, and you take a non-AI practitioner and you ask them, what's so hard about this? For example, for everyone in this room, you intuitively know what this picture is, right? You've got an umbrella, some chairs, the ocean, the sand. This doesn't take any effort. You learn this just by growing up. But to a computer, this is just a sequence of dots and pixels, has no comprehension of what's in this photo. So in computer vision, we solve two problems. The first we call segmentation. It's figuring out where this little straw umbrella ends and the ocean begins, where the chair ends, where the sand begins. Once we've segmented that image and understand what the different contours and parts of it are, we can start to identify the objects in that image so that we actually know that's a chair. You may not be able to see it. There's a sailboat in the ocean back there that we've been able to pick up, and obviously the umbrella in the front. Say, sweet trip, you taught a computer to figure out an umbrella's on the beach. What is this useful for? We'll give you an example of some of the things we're rolling out to help real people. Just last week, we launched assistive technologies that for any one of the billions of images shared on Facebook every day, if you need to, you can have the contents of that image read to you. So for the hundreds of millions of people who suffer some form of visual impairment, you can participate in the rich visual media on Facebook. In this example, you'd see things like tree, sky, outdoor, or two people smiling, sunglasses, sky, outdoor, water. Gives you a real sense of what's in that image. And again, we can do this for every user on Facebook, every moment of the day, for every image uploaded. Allows us to scalably solve access to information for the whole world. But this is computer vision. And that's honestly the place where AI is making the most progress the most quickly. But where some of the really hard problems are is in building systems that truly understand language like we do and understand context in conversations. At last F8, last year, I introduced memory networks. This is our breakthrough technology that took a neural network and paired it with a short-term memory system. So for the first time, you could feed it new information and immediately ask it questions based on that information. In the time since then, we've published 5 papers, been cited over 100 times. We've scaled out the size of the data we can train for memory networks by a lot. And most importantly, we've hooked it up to production. You may have heard about this thing called M. This is a virtual assistant we built that via Messenger allows you to accomplish any task that's legal and you can afford. So this is a sample Messenger session. On the right is Messenger. On the left is what you'd see, a simplified version of what the human operator that's powering M would see. And this is the AI system assisting the human operator in what to do. And this is a really simple example, honestly. And it's taken from what we did yesterday. Let's say I want to book some movie tickets. And what you see here is a series of statements where each statement references the context from the previous. I want to see Zootopia. Great. I need to know where you're going to see it so I can see showtimes. All right, Redwood City. Then I can tell you the showtimes available, like 2:30. That'd be great. Then I need to know how many tickets. That'd be 2. And you realize that note I'm saying, 2 please, references 2 tickets at Redwood City, 2:30, Zootopia. A whole bunch of context in this conversation before. So when you compare this, which is even a very simple conversation, honestly, this is about as easy as it gets for our systems, and you compare it to something like a factual query on search, how far is the moon from the Earth? That's easy. That's relatively easy to understand that answer. This requires context and understanding and building systems that can truly understand it. But things start to get really fun when you put all this stuff together. So you take natural language understanding, speech recognition, speech synthesis, and computer vision, and you put it together into something we call Visual Q&A. This is an actual Android app we built. You can feed it images it's never seen before, and instead of just telling you what's in the image, you can have a dialogue with the system. Let's see this in action.
Is there a baby in the photo?
Yes.
Where is the baby standing?
Bathroom.
What is the baby doing?
Brushing teeth.
Pretty cool, huh? I bet you in the back you can't even see. There is a tiny little toothbrush there that is really hard to see. The baby is actually brushing teeth. So you can imagine systems like this scaled out to the whole world that allows you to not just passively consume information in Facebook, but start to have a dialogue with Facebook about what it is you want to see and what's in that data that you're seeing. Making sure, again, that every moment you spend online, you spend it with the content you want to see, and most importantly, with the people you want to spend it with. That's AI. And again, Joaquin's going to go into lots more detail about some of the cool new stuff we're doing here. Let's finish up talking about VR. It's been a big year for us and for everyone in VR. We've launched 2 consumer products, the Gear VR in collaboration with Samsung in November, and just a few weeks ago, the Oculus Rift. Did you guys get your Gear VR yet? Have you tried it out? So this is awesome. It's an incredible experience. It's the highest quality, inexpensive VR experience you can get. It's portable, great resolution, allows you to do everything. You can play games, have experiences, and you can watch video. We have hundreds of apps shipped on Gear VR, and we've seen more than 2 million hours of video watched. When you think about 360 and VR video, it's fundamentally different than what we think of in just, looking out through a window and square video that we see every day, because it really starts to give you a sense of being there. And so you can have experiences that maybe none of us will ever get a chance to have otherwise. I don't know how many of you are ever going to surf a 20-foot wave in Tahiti, or fly with a pilot in a Blue Angels jet, or travel to the surface of Mars. Probably none of us. But with 360 video, you can start to feel like you're there. And as excited as I am about 360 video, there's still a ton of challenges, technical to solve, in order to make this really work. That's why I was so excited yesterday. We were able to announce Surround 360. This is our camera that allows for amazing capture of 360 content. Because what most people don't know is that most of this content captured today requires lots of manual labor. You have to put together these custom rigs, usually 3D printed. Once you get all the things, you have to take it and post-process it and fix all these artifacts in production. And it's one of the key things limiting an explosion in 360 content is just how hard it is to shoot high-quality content, especially hard if you want to make it 3D and high resolution, both of which Surround can do. But the magic in Surround really is in the software. We take output from 17 cameras, 14 horizontally arrayed, 1 up, 2 pointing down, and we take the data from each of those cameras, And the first thing we have to do is fuse them together to make sure that the overlap in the pixels between the cameras isn't visible, that we don't have any doubling or ghosting of the images. We then need to straighten everything out so it looks like it was caught with just one straight camera. Need to color correct to make sure, again, you can't see any of the seams in there. This is Aquila in the hangar shot with our 360 camera. It is some of the highest quality footage I've ever seen, and it gives you this whoa moment of actually feeling like you're there. This is incredible stuff. But once we've got this amazing video, we have another challenge. You've got to get it down to your phone, to Gear VR, down to your Rift on your PC. We have to do it within the constraints of your internet connection. And that's where the advancements in streaming video come in. Over the last year, the Facebook video team has made multiple improvements and breakthroughs in how we stream 360 video. We've gone through different formats like cube maps or pyramid projections. And most importantly, we've done adaptive streaming, so that as I'm looking at a part of this giant sphere of interactive information, we're showing you the highest possible resolution, taking maximum advantage of the pixels on the screen you're looking at. And then as I spin around quickly to look somewhere else, we immediately bring in that part of the video with a very low amount of delay so that you can see that in high resolution with the rest of it in much lower resolution. Allows you to get much higher resolution at much lower bandwidth. If you haven't seen some of the latest videos in the Gear VR via Facebook, I encourage you to check out this one that shows you a couple of rhinoceroses up close, because it really does feel like you're there. There's no blurriness. It's a true sense of being there. Then there's Oculus Rift. Shipped just a couple of weeks ago. Great reviews. It's an amazing piece of hardware. Years of engineering went in to build the Oculus Rift, to make it a premier system for giving you a true sense of presence in VR. This is made for VR OLED screens, IR LEDs that give you this real-time tracking so your head can move with 6 degrees of freedom and tracked in the virtual world. Ergonomics, so that it's got a set of straps in the back that make it very easy to take it on and put it off. You've got headphones built in, so you don't have to mess with headphones as you take this thing on and off. So it's incredibly comfortable and gives you this sense of presence. The headset itself kind of melts away as you use it. We've had an amazing launch with over 50 titles. Mark showed this video yesterday, some of the amazing experiences you can have with the Rift. And it spans video to fun gaming experiences like visiting alien worlds, flying spaceships, driving in cars, basically anything you can imagine. But when we talk about our vision of social presence in VR, it starts to get really fun when you bring in your hands. This is Oculus Touch, hand-based controllers. They take the same tracking technology, the headset, and put it in your hands, so you can have your hands moving freely in the virtual space, 6 degrees of freedom with no perceptible latency. Also does basic gestures, so you can do thumbs up and point and some other things. Really starts to give you the sense of feeling like you and someone else is in VR. So let's take a look at what this is like. This is the real world on the right here. This is the virtual world on the left. This is Toybox, a technology demonstrator the team built to show it off. And what's amazing is you watch this ping pong paddle here. Watch the hand move and the virtual thing on the right. Can't tell the difference, right? It's incredibly smooth, no delay. And when you put two people in this environment, you start to have a lot of fun. You really start to melt away in terms of this virtual world and start to feel like there's someone there. Yeah, people are kind of goofing off, as you can see. And so there's lots of different things you can do. We've built lots of different experiments to figure out. That was obviously people in the virtual world. There's no reason, because you're in VR, you can't do something more fun. This is a mixed reality shot we did, just experimenting with what it'd be like to have a cartoon avatar. So you're playing a simple game where you're building blocks, trying to hit the blocks to the top of the clouds. This is actually two people in VR, but we've shot what it looks like in the real world with Joyce here. And you can see some of the emotions. We've started experimenting with cheering, and in a minute here, when the tower falls, a little bit of anger. Right? So this is fun stuff. But you know, it's always a little hard to get a sense of presence and immersion and all of this stuff when you're talking about this and you're showing videos. So I thought what we'd do is we'd maybe just go into VR together and see what this is like in the real world. We actually have someone in our office. Mike Booth joined us just a few months ago to start working on some prototypes in social VR. He's sitting in our Menlo Park offices, 35 miles south of here. He's connected in VR. And let's go in together to see him, okay? See how easy that was to get in. Hey, Mike, what's going on, buddy?
Hey, Shrep, how you doing? Sorry I couldn't make it up to F8. I'm down here at Facebook HQ.
That's great. You want to say hi to everyone here at F8?
Hey, everybody at F8. Good to see you, virtually.
All right, what do we got here?
Well, we're standing in a sort of a VR test bed that we've put together to test various experiments that we've put together to see how we can interact together in VR.
Great.
Let me show you a couple here.
Okay.
So this is a 360 photo, like you were just talking about.
Yep.
But it's in a sphere. So why don't you grab that and
Okay.
slide it right onto your face.
Whoa.
There we go. Welcome to St. Pancras Station, London.
Cool. This is
We can go here
amazing.
together.
Yeah. Whoa, check out that clock. That's a really sweet clock. I never noticed that before.
Yeah, it's a fancy clock made by the Dent company. They've been doing that for like 300 years. Same clock as in Big Ben.
Yeah, okay.
Let's keep going. Let's try someplace else here in London. How about
Okay.
Piccadilly Circus?
You know, why do they call it a circus?
Yeah, not so much in the way of elephants and clowns. They call it a circus because it's a circle of buildings.
Ah, circle. I see. Hey, it's one of those double-decker buses. That's pretty sweet.
Check that out.
Yeah. This is really amazing. This is awesome. Okay. Hey, wait. I recognize this. This is a place you can't otherwise easily get to. This is Aquila.
Whoa! Wow!
Yeah, check this out.
This is huge.
Look how big this is. So just get a sense all the way here from my right side, this wingtip over here. You've got 2 engine pods. Right here, he's working on a propeller that would go on the electric engine in that pod. We can put a communications bay in the middle here, and then we've got another 2 engine pods. This thing is just massive, isn't it?
It's amazing. I had no idea it was so huge. And what's really cool is I've never been here. So I feel like you've taken me to like your secret lab. Hey, I have one more place to show you in London. So let's take a look at this here. Let's try that.
Okay. That looks like Big Ben to me.
And there's Big Ben. Yep. This is the Parliament.
Yep. The river.
Behind you is the London Eye.
Where is that? Oh, there it is. Right back there. The London Eye. That's pretty sweet. That's pretty sweet. Cool. Hey, they're getting a selfie in front of Big Ben.
Oh, yeah.
You know, I never really got a selfie in front of Big Ben before.
I may have a solution for that. Another experiment we've been trying is the virtual selfie cam.
All right. Woo! Hey, you got this sweet avatar, and I'm just like the Blue Band group over here. What's going on?
Well, so using these, another experiment here, these pens, you can draw on your avatar and customize yourself, but we've already prepared one for you.
Ah, perfect. So I just put this on?
Yeah, slip it on like a mask.
Whoop. All right, let's do this. Woohoo! Selfie.
There you go. Oh, wait, no, I think you need one more thing.
Wait.
Small detail. Hold on 1 second here.
Okay.
Let's do this.
Uh-huh.
Like this.
Uh-huh.
Like so, let me color this in a little bit, like that.
All right.
Okay, and one more detail here.
All right.
What do you think?
That looks great. Can I put that on?
Yeah, hold still.
All right.
There you go.
Okay. So what do we got? Oh, sweet. Although, you know, if this is a formal occasion, I think we need to hook you up too. So let's,
cool. All right.
Not a pencil, not yellow. Let's go with red bow tie. That's what I'm thinking. What do you think, Mr. Booth?
Tie sounds classy.
Let's
I like
do
it.
this. Class this photo up a little bit. All right.
Right on.
Get rid of that. All right. Hold still, please. Perfect. All right. Now we can do this, right?
All right. Let's get Big Ben in there.
Big Ben selfie in VR.
Selfies.
Woo! Bunny ears. All right.
So, the pose we just took, they're right there on the table.
Oh, cool.
You
check
pick
it
them up,
out.
we can
I nailed the bunny ears. Got that one. That one's pretty good.
Nice bunny
Put that one
ears,
down.
Yeah.
I don't really like that one as much.
No, not good.
I don't really like that one either. How about this one? Can we get this on Facebook?
Yeah, you know, you can post that directly to your wall. Just drop it in this Facebook post office box.
Right here?
Yep.
Bye-bye,
right.
Bits.
There it goes. That is now on your wall.
It's on my wall, publicly available for all to see.
Right now.
Right now. Posted from here. That's amazing. All right, Mr. Booth. I could spend all day in here, but I think I should probably get back to this talk. So,
Right on.
thanks
Good
a lot,
to see
buddy.
you.
We'll see you when I get back down to Melbourne Park, all right? Talk to you later.
Right on. Bye-bye.
Bye. All right. How's that for social presence? You know, I've done that demo a bunch, and it's still freaking fun every time. I've had people tap me like, you got to get to a meeting, Shrep. Get out of VR. So this is a lot of fun, and I'm really excited about the future we're going to build together on this. And even better, we've got Yasser coming up to talk a little bit later this keynote this morning to talk to you about some of the even further advanced research we're going to do to take some of these ideas of social presence and really take it to the next level. So I hope that gives you a better flavor of what we mean when we say VR can be used to connect people. Mike Booth is 35 miles south of here, and we were able to have this thing like we were together and we were in another place. Whether it's London or in the hangar with Aquila, it's a really amazing experience. This is just a prototype, but there's lots of fun stuff coming out soon for VR. I'm excited to see what we build. So that's it. That's an overview of this morning. We've got a lot of great speakers coming up in today's keynote. I want to thank all of you for coming back, F8 again, and thank all of you for being part of our community. I'm so excited to see what we can build together. With that, Christine, you want to come up on stage and talk to us about open source? All right.
Thanks, Shrep. So did you know that every pixel in your newsfeed was delivered and rendered via open source software? Actually, a lot of Facebook apps and services are powered by our open source portfolio. And whether it's newsfeed or how the data is delivered from our data center, and we've shared much of the stack with you, the stack that connects billions, so that you can build with it as well. Open source plays a really important role in how we build. It accelerates the pace of innovation, it validates our code, it gives us fresh perspectives, and it helps us write better software and create better hardware. All this helps us fulfill our mission of connecting the world. Now, I'm on the open source team, so I can tell you how we evaluate the projects that we share. We put a lot of thoughts into the projects, analyzing the viability of every project against 3 criteria. Is the project useful? Will it be transformative? And will there be a thriving community around the project? Let's take the first one. Is it useful? Now, that's an easy one to answer. Yes, of course, at least it's useful to us because every single one of the projects is used somewhere in the Facebook stack. In fact, we don't open source anything unless it's currently being used in production. So these projects are battle-tested at scale and production grade. Let's take a look at an example. Here are the few of the projects at work every time you open up Newsfeed and your Facebook apps. At any given time, these projects are working together in unison, bringing together one of the experiences to life. We have ComponentKit and React Native creating the UI, HHVM serving up the data, and GraphQL sending structured data down to the app. That's what's happening in the Facebook app. And if you look at the whole of Facebook's open source portfolio, there are more than 350 projects on GitHub actively working somewhere in Facebook apps and services. And we've shared these projects with you to help you create great experiences that scale with your audience. You can create these experiences using any combination of these projects. Let's take a look at the F8 app that you've been using over the past few days so we can see how all of this works. One engineer, Alex Kay, built the app in a matter of weeks, both iOS and Android, and he did this all by himself. This was only possible because he was using our open source projects as the major building blocks, from React Native on the front end to Relay and GraphQL driving the back end. And great news, today, we're releasing the code and the documentation behind the F8 app so you can see exactly how all of these projects fit together. Thank you. So here's the second criteria that we evaluate when we're evaluating a new project. We like to ask, is the technology transformative? Our hope, of course, is the community will find that this technology has improved the developer workflow and their experience. We think there are 2 ways that this can happen. Either technology is novel, it's completely new and never been done before, or the tech can lower the barrier of productivity, allowing teams to just move faster while they focus on their core experience and their expertise. It's pretty easy to see that this is working. A lot of companies are building with these open source projects. Each and every one of these companies has used one or more of our projects, improving their developer velocity. It's great to see that all of these companies are adopting our technology, but we've also seen adoption amongst individual developers. For example, in just 3 years since we launched React, 250,000 developers currently have the React developer tools installed. That's amazing. Which brings me to our last criteria when we're evaluating a new project: community. When we think we've got a project that's useful, transformative even, we ask, can we build a community around it, one that will contribute back and one that will continue thriving? As an example of this, at this very event last year, we launched React Native. It's a framework for building native apps using React. As this year's anniversary approached, we took stock of how much the community's efforts have grown and how we've collectively contributed. With that in mind, I have a few announcements. Firstly, if you're integrating Facebook platform into your React Native apps, I'm happy to say that we've heard your feedback, and we're launching the Facebook SDK for React Native with full support for iOS and Android. And this is available on GitHub now. Secondly, our friends at Samsung are building React Native for Tizen, which is a hybrid platform for smart TVs, cameras, and phones. This means that in the future, React Native developers will have the opportunity to build apps that run on Samsung smart TVs. Now, if you had told us a year ago that we'd see React Native on TVs, I think we would have thought that you were joking. And lastly, I'm really excited to announce that Microsoft is bringing React Native to the Windows ecosystem, allowing developers to build native apps that run on Windows 10 through the Universal Windows platform. This gives web developers the potential to have React Native apps running on Windows devices, including PC, Xbox, and phone. And Microsoft is going to contribute this work back as open source to the React Native community. I think the overall message here is that people love React so much that they want to use it and build for it on every platform. And the community is coming together to make this happen. We're excited and, frankly, humbled by the reaction we've seen. Now, I want to pause and highlight the community aspect because this really is an important part of our program. These are a few of our most active contributors, some who have contributed thousands of commits. And whether you're one of the more active contributors or you've just given back one line of code, you are part of an amazing group that, as of today, includes more than 4,500 contributors. Each and every one of these contributors has helped connect more than 1 billion people. And that's really the point. These community-driven open source projects are not just beginning to power the next generation of mobile scale experiences, but they're also helping us connect the world. It's going to take a lot of software and hardware to do this, and we can't possibly build this all ourselves. Through open source, we can do this together. We're really excited about this. We're going to keep building. We're going to keep open sourcing. We're committed to, and we'll keep investing in these communities and keep working with you in the open. Thank you. So now, let me welcome our head of engineering and infrastructure, Jay Parikh, to the stage, and he's going to talk about connectivity.
All right, good morning. You guys having a good F8? Yeah. All right, so by now you've figured out that we take our mission to connect everyone extremely seriously. We're really excited about this. However, this is a really hard problem. And I'm going to take you through some of the ways that we're going to do this over the next 5 to 10 years and how we're going to connect everyone on the planet. First, we need to understand who's connected and who's not. So let's take a look at this map. This shows the world of users today that we think are connected. Now, there is no really good coverage map of the world, but Facebook's data provides a good proxy. This represents 3G and 4G connectivity, which presents or gives the technology that is needed to experience the internet as we do. And it'll scale to be able to deliver internet video, to do VR, and to show off cool demos like Shrup just showed you a few minutes ago. Now, I want to zoom in a little bit because we want to take a look at another area of the world here to kind of highlight the unconnected part of the world. So we're going to take a look at 3 countries in southern Africa: South Africa, Madagascar, and Mozambique. And you can see here that the network connectivity is primarily 3G and 2G. And oh, by the way, 2G connectivity is a technology that's been around for a really long time. It is 1,000 times slower than what we're used to using, and it is largely just useful for delivering text, nothing else. So we think of these people as being barely connected. Now, thanks to the cool work that our Facebook AI research team has done, working with our data science team and our connectivity lab team, we've been able to produce these extremely granular population density maps down to 5-meter resolution, which is about 200 times better than anything prior. Now, you see the area in orange here. That's where people live. Do you guys notice something wrong here? Yeah, there should be a lot more blue on that screen. All of that orange there that's not covered in blue spots are people that we believe are unconnected, that they don't have access to the internet like we do. Why don't they have access to the internet? Well, we think that one of the major reasons is that the infrastructure just doesn't exist near them, that it's too expensive to bring the internet, to drag fiber through the ground, to build these towers and to deploy base stations. In fact, as we've done our studies, we figured out that at least 1.6 billion people in these countries don't have access to the internet. So we started Connectivity Lab a couple years ago with the focus of creating radical new approaches to getting the unconnected connected. Now, we're not looking at solutions that are going to just make things a little bit better. We don't want to make things just a little bit faster to get people connected. We don't want to make it a little bit cheaper. Our rule in a Connectivity Lab is that we're looking for gains in technologies that are going to make things 10x faster, or 10x cheaper, or both. Now, we're working on a very comprehensive set of technologies here, from UAVs to satellites to laser communications, and I'm going to take you through a couple of the projects today that we're working on. Now, first up is our UAV platform. Now, you've seen the video a couple times the last 2 days. I'm going to tell you why it looks like a giant boomerang. So we've built this aircraft and made sure that everything we've done is going to be able to accomplish the mission requirements of this aircraft. We need to be able to fly this airplane for long periods of time, for months at a time. And so we actually had to invent an entirely new aircraft to accomplish this. Why? Because most aircraft today aren't designed to fly for months at a time and to beam lasers across the sky and to bring internet connectivity to rural communities. So one of the most important things is in designing a plane that's going to be airborne for a long period of time is the mass of the aircraft. We have to care about every kilogram, every component on this plane. So what did? We took a look at everything that goes into this plane. First we tossed off the tail. We took off the tail. There's no tail to this plane, which saved a lot of mass and a lot of drag on the plane. But guess what? It makes it really hard to steer. So we have to do a ton of work in the steering components of the plane. The second thing we did is we removed the pilot, removed the cockpit, removed the bathroom. We don't need any of that. But because this plane has no pilot, we need to develop a very sophisticated flight control system so that this plane can fly over an area and deliver connectivity for months at a time continually without interruption. Last thing we did is we took the fuel tanks and we threw them out too. It's too expensive to power this plane off of fossil fuels and to think about the complexities of refueling this plane. So we're powering it off the sun. Now, we took what's left, which is essentially this wing. We built it out of carbon fiber to make it extremely lightweight and to make it look cool. All right, so how is this going to look when it gets deployed? Well, here's a map. Here's a city that has internet connectivity. We imagine that Aquila would be able to be deployed tens or hundreds of kilometers away from the city. These green lines signify laser links from the city where there's internet connectivity to our plane. And it's an extensible platform because as we want to connect more rural communities, these planes will talk to each other via free space optics or laser links. And they'll be able to deliver tens of gigabits per second of data and internet connectivity to these rural communities. And as we connect more, you can see how this continues to scale out. All right, so we're really excited about this. There's a ton of work left here. We're going to be continuing to build it, to test it, and stay tuned. We'll have more updates as we make progress. Now, I want to shift our attention to a new project in connectivity that we've been working on for a while. And it's a proof of concept idea that we've built that also aims to connect people in these rural communities. However, we're going to stick to the ground this time. Now, one of the things that traditional radio communications uses is a single antenna to send and receive data to you at your mobile phone or to whatever device you have. Now, as more users come online, the amount of radio signal that you have kind of gets split up between everybody. And at some point, this becomes really frustrating. This radio tower becomes congested, and what do you want to do? You want to take your phone and check it out the window of your car, right? It doesn't work. So what we've been doing is looking at ways to add antennas to this device. Now, this technique has been used in the industry, and in 4G and Wi-Fi, the telecommunications industry has added a couple more antennas and made things a little bit better. So we thought to ourselves, how do we make this awesome? Well, obviously, we just add a lot more antennas. So we've built this project, Project Ares, with a base station and a radio antenna array of 96 antennas. This thing can support up to 24 data streams today, and we believe that we've set a record at 71 bits per second per hertz from a spectral efficiency perspective. Now, this is a big deal. This is just a huge change in the industry that can help connect people in the rural communities. Now, within the next couple weeks, we think we're going to hit 100 bits per second per hertz, which is just a game changer. Now, we think that this technology is at least 10x. So as I said before, we're looking for these big order of magnitude changes. And we think this is at least an order of magnitude better than what's available today. Let's take a look at what this actually looks like. Here's a video of Project Ares in our lab. This is the antenna array, all 96 antennas. This is the base station. This is where all the processing happens. 6 billion operations every second happening in this base station. And these are the antennas for the client devices. And then finally, you're going to see a video here that depicts all 24 streams coming in at this spectral efficiency of 71 bits per second per hertz. Now, we think this is really important because this is a technology that's known as massive MIMO, and it's being discussed as a way to bring 5G into developed markets. But we want to take this concept of massive MIMO and this really large set of antennas and this really sophisticated code that we've written and use it to connect rural communities. In fact, in our population studies, we figured out that 97% of the people live within 40 kilometers of a city. So we think that Project Ares here and this technology will be able to extend connectivity out to these rural communities in a much, much, much cheaper and much faster way. All right. The last project I wanted to cover here is a project that we've discovered in thinking about connectivity that actually falls into the urban environments. As more people come online, we've noticed that these networks, these fiber networks in these cities, get congested, that people can't do what they want, and that they can't experience these rich videos and these virtual reality and these messaging applications that are being brought to you. So what we've figured out and we're working on is a project known as Teragraph. And what we're trying to do here is build a low-cost, multi-gigabit speed wireless network that will be a distribution network to replace fiber in these dense urban environments. Now, it's pretty simple because we built these very cost-effective nodes that you kind of deploy on lamp posts and utility poles and a couple of buildings. And then from there, you can broadcast out small cell coverage or Wi-Fi. And we think that we can provide the least expensive, the most capacity Wi-Fi network for these urban environments. Now, how does it work? How do we keep the cost really low? How do we make sure we hit this order of magnitude lower cost we want? Well, there's a couple key things here. We're relying on these low-cost commodity WiGig chips to be able to put in these client nodes and these distribution nodes. These are really cheap, they're commodity, they're showing up in your homes and your phones and your other devices. The other thing that we take advantage of is that we use unlicensed spectrum at the 60 gigahertz range. Now, there's lots of spectrum available here, so we have lots of capacity. The other thing that's great, it's unlicensed, so we don't have cost to procure this spectrum. And finally, 60 gigahertz in the industry has always been something that was, frankly, a bit frowned upon because it gets really easily absorbed by water and oxygen. So it doesn't have a very good range. But we take advantage of the fact that it doesn't have a very good range to minimize the interference as we broadcast through the city and to also keep the capacity high. Now, we're also taking advantage of our extensive experience in our massive data centers and our scale-out technology, because we've built a cloud computing controller here that will help route around obstructions and interferences. We've made this whole network IPv6 only as well, and that the system will recover when there are interferences or outages, and it'll be a very high reliable system. Now, we're doing a test at our Menlo Park campus down the street, and we've been able to achieve multi-gigabit per second link-to-link transmission ratios. And this is just awesome, because we're going to be able to bring this high-capacity urban Wi-Fi connectivity solution to bring more people on a line and to do it more affordably. The other thing I'm really excited about is that we're announcing a trial with the city of San Jose. We're actually going live with Terragraph later this year in downtown San Jose. So it's really exciting that we'll be able to see this thing in the wild in downtown San Jose and be able to use it and test it. And from there, we'll be expanding out to more cities around the world. Now, it's not our aim, it's not our goal to keep all this stuff to ourselves. We're developing this technology in the open. We want it to be interoperable. And we're going to continue to work on Terragraph and take the components that we're working on in Connectivity Lab and contribute them to the Telecom Infra project. We founded the Telecom Infra project a couple of months ago with a couple other industry-leading companies, and there's over 300 partners now that have joined this community to expand and to bring more affordable and faster connectivity solutions to help connect the unconnected. All right, so to wrap up here, I think it's important to kind of highlight a couple things. One is our approach here is really comprehensive. From bringing Terragraph in the city to be able to bring more people online and to bring connectivity to them at a cheaper rate, to things like Project Aries that will extend out connectivity to tens of kilometers out to these suburban environments, to our development in UAVs and Aquila specifically, and satellites to bring connectivity to people who are hundreds of kilometers outside of a city. Now, one important note here is that it's not our aim here to build and deploy and to run these networks by ourselves. We're just trying to advance the state of the art. We really want to show the industry that it is possible to build technologies that are 10x faster or 10x cheaper or both, and that we want to help accelerate how people get connected to the internet. Now, we have a long journey ahead. There's still many, many hard challenges in front of us, but I'm excited that we've taken the first couple of steps. Thank you. And next up is Joaquin, who heads our Applied Machine Learning Lab team.
Good morning, everybody. How are you guys doing today? Good. All right. Yesterday, we told you that we are working on AI in order to help people connect and share in more natural and intuitive ways, okay? I like to think about this as we are giving you communication superpowers through AI. And the way we're doing this is we've built this AI backbone that powers pretty much every aspect of the Facebook experience. over 25% of engineers across the company use it to run 50 times more experiments today than a year ago. And this is a big deal because it means that research is hitting production faster than ever. It's powered by a massive 40 petabyte. Oh, my clicker doesn't seem to be working. Oh, there we go. Sorry. All right, sorry. Could we go back to the previous slide? I missed the click. All right, thank you. All right, I was telling you that it's powered by a 40 petaflop GPU cluster, okay? And teams are using it to train massive models with billions of parameters on gigantic training sets with trillions of data samples. What I'm going to do now is I'm going to take you through a couple of examples of how this works, okay? When you load your newsfeed, a personalized AI that learns your preferences analyzes not only every news story available to you, but also all significant old memories. And the cool thing is it's able to generate pretty amazing blasts from the past, like this one I'm going to tell you about, okay? So this here is a post I saw earlier this year of a ski trip 2 years ago. This was the first absolutely amazing ski trip my family and I did together. And the reason it was amazing is that for the first time ever, we were able to ski down the slopes for an entire day together as a pack, even hitting some black diamonds together. So this is a kind of memory that I'll simply never forget. So I went ahead and I shared this post, which is really cool for my dad because he lives in Spain and he really relies on Facebook to keep up with what my family and I do, or rather I should say, to keep up with his grandchildren. That's what he cares about. But the thing is, I posted in English, and my dad does not speak English. Like my dad, most people in our community actually do not speak each other's languages. So what we've done is we've built this machine translation system that is helping 800 million people every single month see translated posts in their newsfeed. Let's take a look at how this would feel for my dad, okay? So he'd see translation and see the translation, which is awesome. All right, the language on Facebook is human to human. It's alive. People use slang. There's regional differences. And some lazy people like me don't even finish their words, right? So you can't use an off-the-shelf translation system because they tend to be trained on things like appliance manuals or government records. So what we did is we built our own from scratch. And in this way, we are working on eliminating language communication barriers, okay? But there are other communication barriers. There are 40 million blind people in our community and about 250 million severely visually impaired. One key component of the AI backbone is a computer vision system that classifies every single image uploaded to Facebook every day into multiple categories. It'll be able to say whether the Eiffel Tower is on this photo or whether there's a cat. And we've used this to build a much more immersive experience for the blind that I'm going to show you right now.
Facebook, search. What's on your mind? Vincent Chung, February 2nd at 3:16 p.m. Amazing ski day at North Star with Joaquin and his family. Photo, image may contain snow, people, outdoors. Elora Islani and 12 others reacted.
All right, so the system was able to detect that there were snow, people, and outdoors in this image, which is great. Building this image classifier is, again, something we really had to do from scratch because the scale and diversity of images uploaded to Facebook every day by far exceeds anything out there. What else could you do if you had such an image classifier? Let's talk about social image search. Imagine that in a few years from now, my daughter is getting married, and I want to go ahead and find that memorable family ski picture, okay? I could go ahead and search my photos, but I'm very disorganized. It's not in my photos, okay? It's somewhere in some photos some friend of mine took, but in a few years, I'll have forgotten who took it. So I could go ahead, using the fact that we can categorize images and type in snow, and then I'd get results. I'd see photos taken by my friends that have been classified as containing snow. Potentially, this could be a huge list, but I got lucky, and the image is right there. So this is pretty cool, but we can do a lot better than that. We're doing research on cracking the image open and understanding it at the individual pixel level. This is called image segmentation. And what we're doing with this is we're building the ability to understand the individual objects that compose an image. Let's just take a look at how this would look like for this specific image.
Person 1. Person 2. Lake. Person 3. Person 4. Tree 2. Snow. Person 4. Skis.
All right, this is totally awesome. And one of the things we can do with this is build much more immersive experiences for the visually impaired, where you could imagine having these talking images where you can swipe with your fingertips and hear what part of the image that is. The other thing you can do is you can imagine us building image search on steroids, where I'd be able to say, don't just get me pictures of snow, get me that one photo where the 5 of us are on skis on the snow. There's a lake in the background. Oh, yeah, and there were trees left and right. OK, so to close today, I'm going to talk about video. As you know, on your phone, videos play silently. So we've gone ahead and built an automatic speech recognition system that is capable of generating closed captions so that you can understand what's going on in the video without having to turn up the volume. Another cool thing we're working on is we're applying face recognition to videos. So this is a research project where Vincent and Connie are at work. Their faces have been recognized, and the video is being tagged with that. And, oh, look at that. In the background, you have Shrep and Mark just walking by. Their faces have also been recognized. What you have now is you have a video that has been tagged with the 4 actors that feature in it, OK? And importantly, the specific frames, the timestamps where they appear, are tagged too. Imagine the power this could give you to search through tens of millions of videos and find specifically the ones that contain the people you're interested in seeing, and also jump straight to the place where they appear. The last thing I'll tell you about today is I'm going to tell you about some research we're doing we're building these 3D convolutional networks that are able to categorize videos. And we're working on making this work sort of for real-time video streams. So for here, for example, you sort of see, fireworks, food, and cat as categories, right? Now, what could we do with this? Well, last week, we announced LiveMap. LiveMap allows you to browse public live videos by location. I'm going to tell you a story. I have a friend, Ari, in the audience. And he's a bit of a baseball nutcase, OK? So we can use our video classifier to allow him to focus only on the videos that are about baseball. So what can he do with that? He can, for example, go ahead and find that game going on in Oakland. There's a game going on in Kansas City. And then maybe there's a game going on in DC. Now, the cool thing about the game going on in Kansas City is that you get 2 simultaneous viewpoints onto the same game, one from inside the stadium and one from outside the stadium. So there you go, Ari. This is a whole new game for you, right there. OK, it's been amazing to be here with you today to tell you about examples of how today Facebook is powered by AI. But more excitingly, with the research we're doing, we're just getting started here. All right, thank you very much. And it's my absolute pleasure to introduce my friend and colleague Yasser from Oculus Research, who is going to tell you about where virtual reality is going.
All right, thank you, Joaquin. Good morning. Today I'm going to talk to you about social presence in VR, why it matters, why it's challenging, and what it'll take to make interactions in VR as rich and engaging as the interactions we're used to in the real world. Imagine a social experience in virtual reality that's completely indistinguishable from a real-world interaction in every aspect, in the way people look, in the way they move, where the technology disappears and you're simply interacting with another person. It would be incredibly compelling, by far the best electronic social experience yet. At the same time, making social interactions in VR as natural as the ones we're used to in the real world is one of the grand technological challenges today. It's a challenge because there's nothing people are more keenly aware of than other people. So the bar for deeply convincing virtual interactions is extremely high. But for the same reason, once that bar is reached, lifelike virtual interactions will be a transformative achievement, vastly expanding our personal worlds and connecting the world together in a way we haven't seen before. The list of ways our personal worlds will get richer is as long as the list of things we do with other people. In fact, it's as long as the list of things we wish we could do with other people, from the way we work, to the way we play, to the way we communicate. Imagine poker night with old college friends who are now scattered around the world. And the experience in virtual reality is real enough that you can tell whether they're bluffing or not. Imagine interviewing at jobs around the country without traveling, and the potential for doing that in a way that's blind to gender or ethnicity. Imagine working with remote teams as effectively as you do if you were in the same room together. You could attend a planning meeting in Tokyo at 10 a.m., work on a joint design with a different team at the main office at 11, and then conduct a sensitive negotiation in New York at noon. And then there's shopping and sightseeing and all the other ways in which we socialize with other people. You could spend Saturday chatting with a friend at a table next to a canal in Venice, jump to LA on a moment's notice to catch a concert with friends, from the front row seats, of course, and finish up at a party. And on Sunday morning, you could drop in to catch up with your parents as you do every week. Proximity would no longer determine who you spent your time with, and the distance between you and the people you care about would melt away. My interest in social VR is personal as well as professional. My extended family lives in Abu Dhabi, some 7,000 miles from my home in Pittsburgh. A very personal example of how distance inhibits personal relationships happened during the birth of my daughter. This is a photograph that was taken right after my daughter's birth. My son took her in his lap, and he looked at her for a moment, then he looked up, and he smiled at me, and I smiled back at him. It's a really cherished memory of mine. I really wish that other members of my family could have experienced a moment like this as well. Unfortunately, there's no technology today that can enable us to make that sort of an emotional connection. It pains me to see my children grow up without really knowing their cousins, their aunts, their uncles, and their grandparents. They visit them once a year, but only for a few jet-lag days, and otherwise know them as moving images trapped behind a computer screen. That's not how kids or any of us build lifelong relationships. Now, your story will be different, but we've all had singular experiences we'd have liked to have shared with friends and families, but we couldn't because of their distance. If we can make it possible for people to experience genuine, deeply convincing social interactions remotely, then these relationships can continue to be living and growing connections instead of connections we struggle to maintain. We're quite far from achieving this sort of social presence in VR, but this is its purpose, the ultimate social platform, where physical distances disappear and we can have growing personal relationships with people across the planet. So, what is social presence in VR and how do we achieve it? Presence has been defined as that experience of being in a place, really feeling like you're there. For those of you who've experienced it in VR, a compelling example of presence is the instinctive hesitation to step off that ledge in front of a deep fall. Even though you consciously know you're in a virtual environment, you just can't get yourself to take that step. That's a sense of presence that VR can deliver today. Social presence is a little different. Social presence is the visceral experience of being aware that someone else is fully aware of you. An example of social presence is the hesitation to do things in front of other people that you would do when you're alone. Dance the way you do when you're alone, give yourself that pep talk in the mirror, and so on. So, there are three couple problems that we have to solve before we achieve social presence in VR. First, we need to capture the subtle motion of people in a non-obtrusive way. Next, we need to efficiently display these subtleties with deeply convincing avatars. And finally, we need to solve a problem called social prediction, which we'll talk more about shortly. But before we strategize about addressing these challenges, we need to ask a question. What makes a social interaction? In the 1980s, researchers created a game called Mafia to study interactions in social groups. Some of you may know it as Werewolf. In the game, a few players are secretly part of the Mafia, and the objective of the rest of the group is to discover who they are. In this video, the guy in the pink shirt randomly accuses the woman in the green jacket of being the Mafia. She denies it, but there's something in her denial that sets two other people off. Let's take a look. So what did they see? There was clearly a signal of some sort because they both independently arrived at the same conclusion. So let's look at this interaction once again from a different perspective. Try to see what set them off. Was it that she stepped back, or that she smiled when she denied it? If you're curious, she was in fact the Mafia. It's hard to say exactly what the signal was, but clearly there was something that suggested deception. And even though it would be difficult to define it precisely, I think we can all agree that there's no doubt there was some sort of a signal. Now, a common misconception is that this sort of signaling occurs primarily with the face. Consider this image. How many of you think he's feeling positive? Good. How many of you think he's feeling bad? Once we see the whole image, it becomes much clearer. How about now? Good or bad? The facial expressions in both of these examples are very similar, but we needed the body to disambiguate his emotional state. This is an extreme example, but the body provides strong context to disambiguate the subtle differences in our social signaling all the time. All right, final example. In this interaction, the child thinks he's playing with the examiner, but she's actually testing to see if he's at risk of autism. She gives him the ball, and he sends it back, but she holds it until he requests for it in some way. And you'll see he'll nod his head momentarily. There. She accepts this as a gesture of request, and then she holds it again, and he does something really interesting with his hands. Just watch his hands. He does this subtle gesture, just opens his hands slightly like this. And she accepts this as a request. It's really fascinating to me that across cultures, age groups, ethnicities, gender, we all immediately understand what this gesture means. The 2-year-old child knew to do it, and even knew that the examiner would understand what the gesture means. And yet there's no unique word for this gesture in any language. And there's nothing unique about this gesture. There are likely hundreds of thousands of such unnamed behaviors that we continuously exchange and effortlessly interpret without even realizing it. This is what the eminent anthropologist Edward Sapir described as an elaborate code that's written nowhere, known to no one, and understood by all. When we interact with one another, we are continually, effortlessly, and subconsciously transmitting and receiving all the subtle elements of the elaborate code. It's what makes a social interaction feel real and immediate. And to produce interactions in VR that feel just as real and immediate, we need a computational understanding of Sapir's elaborate code. And this is really complex, because we need to discover the vocabulary, the syntax, the morphology, the synchrony of social behavior, and all the other structures that we don't even know about. So where are we today in being able to capture the elaborate code? As we saw during Shrep's demo, VR systems today can capture two major signals: the head motion and hand motion of the user. By tracking the motion of the headset, we can get some idea of what the user is paying attention to. And the touch controllers can catch hand signals like pointing and giving the thumbs up. Do you see here? That's enough to do a lot of cool things, but it's only a tiny subset of all the rich and complex signals that humans send each other when they're interacting. The grand challenge in achieving full social presence in VR is how to capture and crack the rest of the elaborate code. It's key to unlocking the full potential of VR to transform our lives. Now, as I mentioned earlier, there are 3 great challenges to achieving social presence today that are nowhere near solved. To understand how they fit together, let's look at the simplest implementation of the social VR pipeline. Take 2 VR users separated by distance and connected over the network. The first challenge is capture. VR systems are usually thought of as the ultimate display, the final display. But to make social presence a reality, we have to make it the ultimate motion capture system as well. It has to be able to capture all of the subtle details of the reaction of the woman in the green jacket, the tennis player's body, the child's hands, and all the elements of the elaborate code. What makes this challenge confounding is that we can't do this with a room full of expensive devices or ask people to wear a full motion capture suit. VR has to be affordable and convenient. And even with expensive equipment, there's no algorithm in existence today that can capture all the nuance and subtle details of the user's face, body, and hands, and do it in real time. This is an example of a capture of the mouth from cameras mounted on the VR headset looking at the mouth of the user. The video on the left drives the avatar on the right, and as you'll see, the capture algorithm works reasonably well for general expressions, but there's a lot of work to do before we can get the subtleties right, especially for speech. We need new algorithms to capture the eye motion, the hand motion, and the full body motion. And once captured, these social signals need to be transmitted and then displayed on the other side, so we can animate and render avatars that are rich and engaging as well. So display is the next challenge. The bar for photorealism in VR is incredibly high, far beyond what we've seen in any prior medium. In this example, you can see from my avatar that the general structure of the face can be captured reasonably well. But there are several important elements missing. The eyes and the mouth are notoriously difficult to get right. And of course, hair. Now, I'm lucky, I'm bald, but I still had to shave for this scan, as you can see from the shaving cuts on my avatar. But there's something else that's missing in this avatar as well, and that's the real challenge. The real challenge is in getting motion right, the facial expressions of the person. There's no animation rig in the world that can capture all the nuances of facial expressions in speech, and this carries over to the body and hands as well. As this face animates, observe all the fine motion and subtle details. Notice how much you understand about his expression from those details. We need new animation and rendering algorithms that are able to reconstruct the subtleties of the elaborate code to users on the other side. The final challenge is social prediction. As the interaction progresses, every step of the VR social pipeline, from capture to transmission to display, will add latency. Thanks to video conferencing, we're all familiar with how disruptive these latencies can be. When a teleconference system lags, the sense of immediacy that real interactions have just disappears. To overcome latency, we need to develop new approaches to predict social behavior out, slightly into the future, so avatars will feel as natural and responsive as real people. This is particularly important for interactions over the internet, which creates latencies that can be long and highly variable. Now, if this concept of social prediction sounds impossible, consider the fact that our brains do it all the time. It's what allows us to function in the real world by continually anticipating the state of mind and intent of others. In the 1960s and 70s, researchers demonstrated this through the famous point light display experiments. If I were to ask you to guess what this collection of points is, I'd likely get as many answers as there are people in the room. Is it a face? Is it a dog? It would effectively be a Rorschach test. But interestingly, the moment the points move, the ambiguity disappears. There's now a consensus in this room about what this collection of points means. But there's more. Not only are we able to infer what was happening, we can also predict what would happen next. I'd expect we'd have a consensus that the next motion will be the up and down motion of a handshake, right? And astonishingly, we know this all from just the momentary motion of 20 two-dimensional points on the screen. Our brains are remarkable inference engines able to draw upon millennia of evolution and a lifetime of experience to transform these sparse points into fleshed-out people in our imagination, and to predict the next actions of those imagined people as well. The challenge of making the pipeline of social VR work is to learn how to computationally do the same sort of inference and prediction. Now, These kind of pipeline diagrams produce an illusion of separation between the parts of the pipeline. But in fact, the three challenges are tightly coupled to the elaborate code that we have to discover. We need to know what is absolutely necessary to sense, to build affordable, unobtrusive hardware that can capture the signals of the elaborate code. We need to know what to animate and render to convey the signal in a natural and deeply convincing way. And we need a computational understanding of the code for social prediction to overcome latency. It's a maxim of science that we first need to be able to measure what we want to predict. Cracking the code will require understanding social behavior in a far deeper way than has ever been attempted before. To do exactly that, my students and I built a facility at Carnegie Mellon University called the Panoptic Studio. It was designed to measure social interactions at the highest level of detail with over 500 precisely synchronized cameras capturing the inside of the dome. As we walk in, you'll see there's enough space for several people to interact naturally, and each of these black dots that you see on the wall is a camera looking out into the space. With this kind of input, it's easy to... So this is what a few hundred videos of something look like. And with this sort of input, it's easy to produce three-dimensional videos. Now, while this may look somewhat compelling, it captures only a series of 3D structures without any understanding of what the user is doing. It won't help us understand what's important to capture, what's important to display, or how to predict out into the future. What's much more interesting and important is the ability of the studio to capture unconstrained 3D motion. In this scene, confetti is flying around the inside of the dome. And you can see it can reconstruct this unconstrained motion inside the space. Why this is important is that the dome is now a large, massive, markerless motion capture system that doesn't care what the movement is inside that space. It can provide you with a measure of that motion. Let's see what happens when there are people inside the space. All right? There are two people playing with a volleyball. And the system can capture hundreds of thousands of points on each of the players, capturing all those nuances of movement that we talked about earlier. Here's that mafia sequence I showed you earlier. To demonstrate the point, we've automatically marked and tracked anatomical landmarks on the face and body using a state-of-the-art computer vision algorithm. I hope you'll agree that we've made sensible choices on the most important points on the body. See if you can still see what you think you saw when you saw deception earlier, when I remove the video, and just play the points. Somehow, when the subtleties and the details are gone, that signal that we all saw is lost. The Panoptic Studio can capture the subtle motion of the full social group at much higher, at unprecedented levels of detail. And I'm excited about how much more we can discover about how people interact with each other. Now, the point of this is obviously not to install a crazy dome in everyone's living room. The purpose of facilities like the Panoptic Studio is to capture the raw data from which we can discover the structure of the elaborate code, and to endow virtual systems with the sort of imagination that we talked about before. We're, of course, a long way from cracking the code and producing a computational model of social interaction, but a lot of progress has been made, and I'm confident that we will get there. Although it's not possible yet to say when that will happen, but once we're able to experience full bandwidth social interactions, it'll change everything. Social VR done right has the potential for the very first time in history to let us define our tribe, who we hang out with, who we collaborate with to do great things, not based on proximity or happenstance, but by personal choice. As we saw earlier, the first wave of VR interactions will be stylized avatars. And even with such a tiny subset of behavior being transmitted, it was so engaging. But the full power of social VR will be realized when we're socially present with real people that we recognize and care about. Once that happens, we will see the emergence of a new social fabric with emotional connections that can grow and deepen with anyone, anywhere in the world. There are deep and interesting grand technical challenges we need to solve before we realize this vision. But when we do, I'm excited by how it will change the way we live on this world with each other. Thank you. Thank you for coming to F8 and enjoy the rest of the conference.